Okay, so for the following circuit here, we have to find the voltage at each of these capacitors. Okay, so to actually solve for the voltage at each of these capacitors, you need to find the capacitor equivalent. So let's start by combining these two. So these two are in parallel. So it'll be 40 plus 20. So this one will be 60 millifards. Now these three, they're all in series. So to combine them will be 1 over 20 plus 1 over 30 plus 1 over 60 to the power of minus 1. Okay, and this will give you your capacitor equivalent. So 1 over 20 plus 1 over 30 plus 1 over 60. That's, hold on. Sorry, give me a quick second. That's, that's 10, 10 millifards. Okay, so 10 millifards, 2 fards. That's 0.01 fards. Okay, so that's your capacitor equivalent. And we also know what our voltage is. Voltage is 30 volts. Now, with this information, we need to find the charge value, like the charge of the circuit. So the charge Q will be equal to the capacitor equivalent times the voltage. Okay, so capacitor equivalent is 0.01. The voltage is 30. So our charge will be 0.3 coulombs. Okay, this is coulombs is for charge. Now that we know our charge, we can find the voltage at each of these capacitors. So since we know charge is equal to the capacitor times the voltage, that means charge over voltage is equal to the charge over capacitor is equal to the voltage. So okay, so for voltage 1, it'll be the charge, which is 0.3 coulombs all over the capacitor. So that's 20 millifards, and 20 millifards is 0.02 fards. So let me see what that gives me. So 0.3 divided by 0.02, that's 15 volts. Now V2 will be 0.3 fards all over 0.03 0.3 coulombs all over 0.03 fards, and that will be 10 volts. Now the mistake comes when you do the 40 millifard one. So if you do V3 is equal to V3 is equal to 0.3 coulombs all over 0.04 fards, you're going to get 7.5, right? But that's not the right answer, okay? This is wrong. The reason is the sum of all the, so if we do a KCL, the sum of all the voltages added up should be equal to 0. So, so when it hits a negative 30 terminal, it's going to be minus 30 plus V1, so minus 30 plus 15, then V2 plus 10 plus 7.5. And that gives you 2.5. That must mean that V3 is something else, and V3 we can solve by doing this. So let's redo the sum thing again. So it'll be minus. Let me write it here. Minus 30 plus V1 15 plus V2, which is 10, plus V3, and if you rearrange, so minus 30 plus 15 plus 10, bring it to the other side. So V3 will be equal to 5. Okay, all of this has to equal to 0. So that means V3 is equal to 5 volts. And with that information, this is also, hold on. This also should be equal to 5 volts. The capacitor for the 20 millifarad capacitor, sorry, the voltage for the 20 millifarad capacitor, this is also 5 volts. Because if you do the loop here, it enters the V3, which is minus 5, and then there'll be another, let's say this is V4, which is 5, so minus 5 plus 5, that's 0, okay? So these are your final answers.